When we think of a dangerous fish, our minds often conjure images of powerful jaws and lightning-fast predators, creatures of raw, untamed power. These are the ocean's most iconic hunters, their presence a testament to millions of years of evolutionary refinement. We might picture the great white shark, a magnificent hunter perfectly adapted to its marine realm, or the mako, whose speed is unmatched in the open sea. But the true story of the ocean's most dangerous fish is far more complex and profound than a single species or a single moment in time. It is a tapestry woven from countless forms, some bold and visible, others hidden and lethal. It is a narrative that stretches back over 400 million years, a saga of evolution, extinction, and extraordinary resilience. The ocean's architects have shaped not only their own destinies, but the very structure of life beneath the waves. The most dangerous fish are not simply those that pose a threat to others, but those whose very existence or absence has the power to shape the destiny of the entire marine world, and ultimately the planet itself. Their influence radiates through every level of the food web. They are the architects of the ocean, the load-bearing pillars of a system that provides half the oxygen we breathe and regulates our global climate. Their movements and migrations drive nutrient cycles, supporting life from the smallest plankton to the largest whales. Our journey begins in the primordial seas, a time long before the continents had settled into their familiar shapes. The ocean was a vast, mysterious expanse, teeming with possibilities. Around 430 million years ago, life was undergoing a radical transformation. The first fish appeared, their bodies armored with bony plates, their forms unlike anything alive today. The oceans, once dominated by simpler organisms, were becoming a crucible of innovation. New body plans emerged, and the first vertebrates began to outcompete their invertebrate ancestors. It was here that the first vertebrates with backbones began to emerge, setting the stage for an evolutionary explosion that would eventually give rise to every fish, reptile, bird, and mammal on Earth, including ourselves. The backbone became a blueprint for complexity and adaptability. These ancient waters were a theatre of constant competition, where new forms of life were tested against the unforgiving pressures of survival. Predators and prey evolved in tandem, each shaping the other's fate. Understanding this deep history is crucial, for it reveals that the intricate web of life we see in our oceans today is the result of an immense and interconnected story, one in which every creature plays a vital role. Coral reefs, kelp forests, and open ocean gyres all depend on the balance maintained by these architects. The concept of danger in this context extends beyond mere predation. It encompasses the power to alter entire ecosystems, to tip the scales between abundance and collapse. The most profoundly dangerous fish throughout history have been those whose disappearance could trigger a catastrophic collapse. Their absence can unleash chain reactions that reverberate through every layer of the ocean. They are the keystone species, the apex predators, whose presence keeps populations in check and prevents any one group from overwhelming the system, and even the smallest forage fish that form the foundation of the marine food web. These tiny architects feed countless predators and recycle nutrients, sustaining the ocean's productivity. When these critical components are removed, the entire structure falters. Coral reefs crumble, kelp forests vanish, and the ocean's resilience is tested. Ecosystems unravel, biodiversity plummets, and the life support systems of our planet are compromised. The ocean's architects are not just builders, they are guardians of stability. from the armoured giants of the Devonian period like Dunkleosteus, whose jaws could crush bone, to the invasive species of the 21st century, such as lionfish and crown-of-thorns starfish, whose unchecked spread threatens native communities. The story of dangerous fish is a lesson in the delicate balance that sustains life. Every species, from the smallest plankton eater to the largest hunter, plays a part in this intricate equilibrium. It is a reminder that the greatest danger of all is not what these creatures do, but what we risk losing if we fail to protect them and the world they inhabit. The disappearance of even a single architect can echo through time. As we delve into this ancient and ongoing story, we will uncover the rise and fall of incredible predators whose reigns shaped the course of evolution. Witness the remarkable survival of ancient lineages, living fossils like the coelacanth and nautilus, whose continued existence bridges past and present. And explore the modern challenges that threaten to unravel this delicate tapestry. Pollution, overfishing, and habitat destruction now test the resilience of the ocean's architects as never before. We will see how the loss of a single type of fish can have consequences that ripple across the entire globe, affecting everything from coastal economies to the very air we breathe. The ocean's architects are the silent engineers of planetary health. This exploration is not just a journey into the past, it is a critical examination of our present and a call to action for our future. The lessons of the ocean's architects are written in every reef, every current, every breath of wind. The fate of the oceans is inextricably linked to our own, and by understanding the forces that have shaped marine life for millennia, we can better appreciate our responsibility to safeguard it for generations to come. The ocean's enduring architects continue their silent work, building the foundation for all life on Earth. The Devonian period, which began around 419 million years ago, is rightly known as the Age of Fishes. During this time, the seas transformed into vast living laboratories where evolutionary experiments played out on a grand scale. The oceans witnessed an unparalleled burst of vertebrate evolution, giving rise to an astonishing diversity of aquatic life. Jawless fish, once the only vertebrates, were soon joined by new forms with powerful jaws and innovative body plans. Among the most formidable of these new creatures were the placoderms, a class of armoured fish that came to dominate the marine world. Their bodies were encased in interlocking bony plates, forming a natural suit of armour. These were not fish as we might recognise them today. Their anatomy was alien. Massive armoured heads, jointed necks and jaws that could snap shut with astonishing speed. Encased in thick bony plates that formed a protective shield around their head and torso. They were the heavyweights of the ancient seas, their armour both a defence and a weapon. For nearly 60 million years, placoderms were the undisputed rulers, evolving into a vast array of shapes and sizes. Some hugged the seafloor, while others, like the colossal Dunkleosteus terrelli, became the ocean's apex predators. Dunkleosteus was a creature of terrifying power and efficiency, a true monster of the deep. Its massive silhouette cast a shadow over the Devonian seascape, inspiring awe and fear in equal measure. Growing up to 8.8 meters in length, it was one of the largest marine predators the world had ever seen. Its body was built for sudden bursts of speed and overwhelming force. But its size was not its only weapon. Dunkleosteus possessed a jaw mechanism unlike anything else in the Devonian seas. Instead of conventional teeth, Its powerful jaws were lined with razor-sharp, self-sharpening bony blades. These blades slid past each other like scissors, remaining lethally sharp with every bite. Modern biomechanical studies estimate that its bite force was immense, reaching up to 8,000 newtons at the tip of its fangs, a crushing power comparable to that of a Tyrannosaurus rex. This allowed it to puncture armor and bone with ease. This devastating bite allowed Dunkleosteus to shear through the tough armor of other placoderms and even hunt the primitive sharks that shared its waters. Few creatures could escape its relentless assault. It was an apex predator in every sense, sitting at the very top of the food chain and shaping the evolutionary pressures on all other marine life. Its presence forced prey species to adapt or perish. The reign of these armored titans, however, was not to last forever. Subtle shifts in ocean chemistry and climate began to erode their dominance. Towards the end of the Devonian period, the planet experienced a series of catastrophic environmental changes, culminating in a mass extinction event known as the Kelwasser event. Volcanic activity, fluctuating sea levels, and anoxia combined to devastate marine ecosystems. This global crisis, which unfolded around 372 million years ago, led to a dramatic drop in oxygen levels in the oceans and wiped out an estimated 75% of all species on Earth. The seas became graveyards, littered with the remains of once thriving life. The placoderms, including the mighty Dunkleosteus, were among the casualties. Their specialized bodies, once their greatest strength, could not adapt to the rapidly changing world. After 60 million years of dominance, these incredible armored fish vanished from the fossil record completely, leaving a void at the top of the marine food web that would soon be filled by other, more adaptable survivors. The story of Dunkleosteus serves as a powerful lesson in the dynamics of life on our planet. Its rise and fall are etched into stone, a testament to both evolutionary triumph and vulnerability. It demonstrates that even the most dominant and seemingly invincible predators are vulnerable to large-scale environmental shifts. The balance of power in the ocean is always in flux. Their extinction highlights the fragility of even the most robust ecosystems when faced with rapid and profound change. The interconnectedness of life means that no species is truly isolated from the fate of others. The fall of the placoderms was a pivotal moment in Earth's history, closing one chapter of marine evolution and opening another. New forms would rise to fill the void, each shaped by the legacy of those that came before. It cleared the way for new groups of fish to rise and diversify, creating the evolutionary pathways that would eventually lead to the marine ecosystems we know today. The echoes of Dunkleosteus still ripple through the oceans. Their legacy, however, was far from over, as a surprising discovery would later reveal. For much of scientific history, placoderms were regarded as an evolutionary curiosity, impressive in their armored appearance, yet dismissed as a failed experiment in the grand narrative of vertebrate evolution. Their fossilized remains, encased in stone for hundreds of millions of years, seem to tell a story of brute force and abrupt extinction. These formidable fish dominated the Devonian seas, their heavy bony plates forming a natural shield against predators and rivals alike. They were apex predators, patrolling primeval oceans with powerful jaws and an imposing presence, shaping the marine ecosystems of their time. For decades, their narrative was one of raw strength, creatures defined by their armor and predatory prowess, seemingly lacking the subtle innovations that would mark true evolutionary progress. But in 2008, a groundbreaking discovery in Western Australia's Gogo Formation would forever alter our perception of these ancient fish and their evolutionary significance. Here, embedded in ancient limestone, researchers uncovered the exquisitely preserved fossil of Deadliest Attenborough, a small placoderm whose name means Attenborough's motherfish. What set this fossil apart was its astonishing contents. A perfectly preserved embryo still connected to its mother by a mineralized umbilical cord. This rare glimpse into ancient reproduction offered a direct window into the lives of creatures that swam the seas nearly 400 million years ago. This fossil, dating back 380 million years, stands as the oldest known evidence of live birth in any vertebrate. It was a revelation that shattered previous assumptions about early fish reproduction. The discovery proved that placoderms were not simply external egg layers. Instead, they had evolved complex reproductive strategies, including internal fertilization and the nurturing of embryos within the mother's body, a level of sophistication previously thought to have emerged much later in vertebrate history. This single fossil pushed the origins of live birth back by 200 million years, rewriting the evolutionary timeline and placing placoderms at the forefront of vertebrate innovation. Far from being an evolutionary side note, placoderms were pioneers. They represent the earliest known ancestors of all jawed vertebrates, a lineage that would eventually give rise to sharks, bony fish, amphibians, reptiles, birds, and mammals. The legacy of placoderms is not distant or abstract. It is a direct line that connects the armoured fish of the Devonian to every backboned animal alive today, including us. The implications of this discovery are profound, reshaping our understanding of how complex life evolved and how key biological innovations emerged. The mechanisms that allow for the development of complex vertebrates, including internal fertilization, live birth, and embryonic nourishment, can all be traced back to these ancient armored fish. Placoderms were also among the first to develop jaws and paired fins, innovations that revolutionized feeding and movement, setting the stage for the explosive diversification of vertebrate life. These evolutionary breakthroughs gave vertebrates the tools to become agile hunters, effective defenders, and attentive parents, traits that would ensure their survival and success for millions of years. Placoderms were not just formidable predators. They were evolutionary trailblazers, laying the groundwork for the astonishing diversity of vertebrate life that would follow in their wake. Their legacy is inscribed in the very DNA of every jawed vertebrate, a genetic inheritance that continues to shape life on Earth. So, when we gaze upon the fossilized skull of Dunkleosteus, we are not merely witnessing the remains of a prehistoric monster, but glimpsing a distant ancestor whose innovations echo through time. We are looking at a member of the group that set in motion the evolutionary cascade leading to the incredible variety of vertebrates, including ourselves. The story of the placoderms is a vivid reminder that all life is interconnected, woven together in a single, ever-branching family tree that spans the ages. Even the most fearsome creatures can harbour secrets that illuminate our own origins, revealing unexpected connections across deep time. Though placoderms vanished in a mass extinction, their evolutionary gifts endure, a testament to their role as architects of vertebrate success and a foundational chapter in the ongoing story of life on Earth. As the placoderms vanished in the turmoil of the late Devonian extinction, a profound power vacuum emerged at the summit of the marine food web. The oceans, once dominated by armored giants, became a realm of opportunity and uncertainty. Into this void stepped a lineage that had long lingered in the shadows: sharks. These early cartilaginous fish, once overshadowed by the armored placoderms, now found themselves poised to ascend as the new rulers of the sea. Sharks first appeared over 400 million years ago, predating even the earliest trees. Their evolutionary journey is marked by extraordinary adaptability, allowing them to survive radical shifts in climate, ocean chemistry, and the rise and fall of entire continents. Over the eons, sharks have weathered at least 4 of Earth's 5 great mass extinctions. Their ability to adapt, whether by altering their reproductive strategies, shifting their diets, or evolving new hunting techniques, has enabled them to persist while countless other lineages vanished. The secret to their resilience lies in their anatomy and senses. Sharks possess a cartilaginous skeleton, granting them unmatched flexibility and speed. Their skin, covered in dermal denticles, reduces drag and noise, making them silent hunters. Their senses are finely tuned. Electroreception allows them to detect the faintest electrical signals from prey, while an acute sense of smell can trace a single drop of blood in millions of gallons of water. Today, sharks occupy the apex of many marine ecosystems. As top predators, they exert a powerful influence over the structure and health of oceanic communities, shaping the very fabric of marine life. The modern great white shark, for instance, is a descendant of a lineage stretching back 3.5 million years. Yet it carries within its DNA the legacy of 400 million years of evolutionary refinement, an apex predator honed by time. As apex predators, sharks regulate the abundance and behavior of species below them. Their presence influences where prey congregate, how they feed, and even their reproductive strategies, creating a ripple effect throughout the ecosystem. By targeting the weak, old, or diseased, sharks act as natural health officers, ensuring that fish populations remain robust and genetically fit. This selective predation helps prevent the spread of disease and maintains the vitality of prey species. Sharks also prevent any single species from becoming overly dominant. Without their regulating presence, herbivorous fish or invertebrates could overgraze seagrass beds or coral reefs, leading to habitat collapse and loss of biodiversity. The presence of sharks maintains a delicate equilibrium, supporting the stability and diversity of entire marine communities. Their influence extends from the smallest plankton to the largest whales, weaving a complex web of interdependence. When apex predators like sharks are removed, the consequences are immediate and far-reaching. The resulting imbalance triggers a trophic cascade, where unchecked prey populations disrupt the ecosystem's natural order. In the absence of sharks, populations of mid-level predators, such as rays and smaller sharks, can surge uncontrollably. These species, no longer kept in check, exert intense pressure on their own prey. Rays, for example, may devastate shellfish beds, while unchecked predatory fish can decimate populations of smaller fish and crustaceans, unraveling the intricate balance of the ecosystem. In some regions, the loss of sharks has led to the collapse of entire scallop fisheries, as exploding ray populations consume all available shellfish, leaving once thriving habitats barren. The absence of these top guardians destabilizes the entire architecture of the marine ecosystem, resulting in a less resilient, less productive, and far less diverse ocean environment. In this light, the most dangerous scenario is not the presence of sharks, but an ocean stripped of them, a silent sea where balance has been lost. Sharks are more than predators. They are ecosystem engineers. Their movements stir nutrients, their predation shapes communities, and their very presence fosters resilience and health in the oceans. For hundreds of millions of years, sharks have patrolled the oceans, maintaining the balance that allows coral reefs to flourish, seagrass meadows to thrive, and a dazzling array of marine life to coexist in harmony. Their evolutionary success is a testament to their adaptability and ecological importance. Yet, despite their ancient lineage, their future is now threatened by forces beyond their evolutionary experience. As shark populations decline, the oceans face an uncertain future. The loss of these apex predators is not just the disappearance of a remarkable lineage, but the unraveling of a system that has supported life for eons. The balance of power in the ocean depends on the continued presence of sharks, guardians of the deep and architects of marine stability. While ancient predators like Dunkleosteus once dominated primordial seas, and modern apex hunters such as sharks continue to shape marine ecosystems through their natural predatory roles, a new, insidious threat has emerged beneath the waves, one that disrupts the delicate balance of entire oceanic communities: the invasive species. Among the most visually arresting and ecologically devastating is the red lionfish, Pterois volitans, instantly recognizable by its bold stripes and extravagant venom-tipped fins. Native to the vibrant coral reefs and lagoons of the Indo-Pacific, the lionfish evolved in a world teeming with natural checks and balances. Its ornate fins serve as both a warning and a weapon, concealing venomous spines capable of delivering a painful sting to would-be predators. Yet this beauty masks a voracious appetite and an unparalleled ability to devastate new environments, making the lionfish one of the most destructive marine invaders ever recorded. The lionfish's journey into foreign waters began quietly in the mid-1980s, likely the result of aquarium hobbyists releasing unwanted pets into the Atlantic Ocean near Florida. This seemingly minor act set in motion an ecological upheaval. From a handful of individuals, the lionfish population exploded, launching a relentless invasion. Within decades, lionfish spread rapidly across the Caribbean, the Gulf of Mexico, and up the entire eastern seaboard of the United States, colonizing habitats from shallow reefs to deep wrecks. The lionfish's extraordinary success as an invader is rooted in a suite of biological advantages. In the Atlantic, the lionfish found a new home, teeming with prey and virtually free of natural enemies. Unlike in its native range, here it faces no predators capable of curbing its numbers. Native reef fish, unfamiliar with the lionfish's appearance and hunting tactics, failed to recognize it as a threat, showing no instinctive fear or defensive behaviors. Compounding the problem, lionfish are prolific breeders capable of reproducing year-round in warm waters. A single female can release up to 2 million buoyant eggs annually, which drift on ocean currents and settle far from their origin. This reproductive strategy enables populations to surge exponentially, overwhelming new territories in a matter of years. Lionfish are also highly efficient, opportunistic predators, consuming more than 70 species of reef fish and crustaceans, from tiny gobies to juvenile groupers. Their insatiable appetite leads to dramatic declines in native fish populations, unraveling the intricate web of reef life. Juvenile fish, essential for replenishing future generations, are especially vulnerable to lionfish predation. Scientific research has revealed the staggering scale of this impact. In the Bahamas, studies found that a single lionfish on a small patch reef can reduce the recruitment of juvenile native fish by up to 93% in just 5 weeks, a near collapse of the next generation. This relentless predation leaves coral nurseries eerily empty, with few young fish surviving to adulthood. The result is a rapid decline in biodiversity, weakening the resilience and health of entire coral ecosystems. Today, the lionfish is recognized globally as one of the world's 100 worst invasive species, a testament to its ecological destructiveness. The severity of the invasion is compounded by decades of overfishing, which has removed many native apex predators from reefs, such as large groupers and sharks, that might otherwise have limited the lionfish's spread through predation or competition. The lionfish thus represents a new kind of marine danger, one whose threat arises not from its place in the food web, but from its displacement into ecosystems unprepared for its arrival. Like a biological wildfire, the lionfish spreads rapidly, consuming resources and leaving devastation in its wake. Coral reefs, lacking natural defenses against this invader, are left vulnerable and diminished. Yet, amidst this ecological crisis, there are glimmers of hope. In recent years, targeted removal efforts have begun to make a difference. In areas where lionfish are systematically culled and where native predators are recovering, localized reductions in lionfish numbers have been observed. In some Caribbean reefs, intense intervention has led to the return of vibrant fish communities and healthier coral. Scientists monitoring these sites have documented a swift rebound in native fish populations, showing that when the pressure of lionfish predation is lifted, coral ecosystems can begin to heal, restoring the intricate balance that sustains ocean life. While our attention is often drawn to the large and charismatic predators of the ocean, the true foundation of marine ecosystems rests on the fins of much smaller, less conspicuous fish. These are the forage fish, species like anchovies, sardines, herring, and menhaden. They are the humble, silvery schools that form a critical link in the marine food web, converting the energy from tiny plankton into a vital food source for nearly everything else in the ocean. From seabirds and marine mammals to larger fish like tuna and sharks, countless species depend on these small, oily fish for their survival. Their sheer numbers are staggering, with a global biomass estimated to be between 1 and 2 billion tons. They are, in effect, the beating heart of the ocean's circulatory system. The life strategy of forage fish is one of abundance. A single anchovy might only live for 3 to 5 years, but during its short life, it can produce tens of thousands of eggs, ensuring the continuation of its vast populations. This immense productivity fuels the entire marine food web. However, their importance extends far beyond being a food source. Forage fish play a crucial role in regulating our planet's climate. They feed on phytoplankton, the microscopic marine plants that produce approximately half of the world's oxygen through photosynthesis. By grazing on these phytoplankton blooms, forage fish help to control their growth and are instrumental in the process of carbon sequestration, where carbon from the atmosphere is drawn down and stored in the deep ocean. Forage fish move in tightly coordinated schools, creating mesmerizing patterns that confuse predators and increase their chances of survival. These synchronized movements are not only a defense mechanism, but also help to distribute nutrients throughout the water column as the fish migrate vertically each day. In regions where forage fish thrive, the ocean is vibrant and full of life. Coral reefs, kelp forests and open ocean habitats all benefit from the presence of these fish, as they transfer energy from the smallest plankton to the largest predators. Many forage fish feed at night, rising from the depths to consume zooplankton and returning to deeper waters by day. This daily migration helps cycle nutrients and supports a diverse array of marine organisms, from tiny invertebrates to massive whales. Juvenile forage fish provide essential shelter and food for countless marine creatures. Their presence supports the early life stages of many species, ensuring the resilience and diversity of ocean life. Seasonal migrations of forage fish are synchronized with ocean currents and temperature changes, shaping the movements of entire ecosystems. These migrations trigger feeding frenzies and breeding events for predators, maintaining the balance of marine populations. In coastal areas, forage fish help maintain the health of kelp forests and rocky reefs by grazing on algae and keeping the ecosystem in balance. Their constant movement stirs up sediments, oxygenates the water, and supports the growth of marine plants. The presence of forage fish near the ocean surface attracts a multitude of species, creating hotspots of biodiversity. These areas become nurseries for young fish and feeding grounds for larger animals, supporting the entire marine community. Even the physical structure of forage fish, streamlined bodies, reflective scales, and efficient gills, demonstrates their adaptation to a life of constant movement and survival in vast open waters. In upwelling zones, where nutrient-rich waters rise from the deep, forage fish populations explode, fueling some of the most productive ecosystems on Earth. These hotspots support immense gatherings of marine life, from tiny crustaceans to apex predators. The cycling of nutrients and energy through forage fish is a cornerstone of ocean health. Without them, the transfer of life-sustaining energy from the sunlit surface to the deep sea would be broken, and the ocean's intricate balance would collapse. Forage fish are the silent architects of marine abundance. Their presence ensures that the ocean remains a place of wonder, diversity, and resilience for generations to come. The ocean is an intricate and finely balanced system, a complex architecture where every species, from the smallest anchovy to the largest shark, serves a purpose. Each organism is woven into a vast living tapestry, its presence and actions influencing countless others in ways both subtle and profound. Each one is a load-bearing pillar, supporting the structure as a whole. Remove a single pillar and the entire system begins to tremble, its stability threatened by the loss of even the smallest component. The stories of Dunkleosteus, sharks, lionfish and anchovies all illustrate a single fundamental truth. When one of these pillars is removed, the entire edifice is at risk of collapse. The disappearance of a single species can send shockwaves through the food web, destabilizing relationships that have evolved over millions of years. The loss of a key species, whether an apex predator or a foundational forage fish, triggers a cascade of consequences that can unravel an entire ecosystem with shocking speed. The intricate balance between predator and prey, grazer and algae collapses, leading to unpredictable and often irreversible changes. We are now witnessing these collapses across the globe, driven by the unprecedented pressures of human activity. The relentless extraction of marine life, combined with habitat destruction and climate change, is pushing many ecosystems to the brink. Overfishing is perhaps the most direct and devastating of these pressures. Industrial fleets sweep vast areas of ocean, removing not only target species but also countless unintended victims. Bycatch that includes everything from juvenile fish to endangered turtles. A stark example can be seen in the waters off the coast of West Africa, where decades of unsustainable fishing by international industrial fleets have decimated fish stocks. Once abundant populations have dwindled, leaving behind empty waters and silent reefs. Populations of species like the round sardinella, a vital forage fish, have plummeted. Their absence ripples outward, depriving predators of food and altering the very fabric of the ecosystem. This has not only destroyed the livelihoods of local artisanal fishers who have depended on these stocks for generations, but has also triggered a wider ecological crisis. The collapse of one species can lead to the decline of many others, as food webs unravel and competition intensifies for what little remains. With their primary food source gone, populations of larger fish, seabirds and marine mammals have declined. The ocean's top predators, once symbols of abundance, now struggle to survive in a world where their prey has vanished. The system has become impoverished, a shadow of its former abundance, demonstrating how the removal of one pillar can lead to the progressive weakening of the entire structure. Biodiversity shrinks, and the resilience of the ecosystem erodes. Habitat destruction further exacerbates this crisis. The physical damage inflicted by anchors, dredging and coastal development strips away the essential refuges and nurseries that countless species depend on. The degradation of coral reefs, mangrove forests and seagrass beds, the critical nurseries and feeding grounds for countless marine species, removes another set of essential pillars. Without these habitats, the next generation of marine life struggles to survive. Coral reefs, bleached and weakened by rising ocean temperatures and pollution, can no longer support the vibrant communities of fish that depend on them. The loss of colour is more than aesthetic. It signals the death of an entire ecosystem. The introduction of invasive species like the lionfish into these already stressed environments is like adding fuel to a fire, accelerating the decline and pushing these fragile ecosystems towards a point of no return. Invasive predators outcompete and consume native species, further destabilizing the system. The result is a less resilient, less diverse and less productive ocean. The loss of biodiversity weakens the system's ability to recover from shocks, making it more vulnerable to future disturbances. This cascading collapse is not a distant, abstract threat. It has tangible consequences for humanity. The effects ripple from the depths of the ocean to the heart of coastal communities and beyond. It jeopardizes global food security for the billions of people who rely on seafood as their primary source of protein. As fish stocks dwindle, prices rise, and access to nutritious food becomes increasingly uncertain. It destabilizes coastal economies and threatens the livelihoods of millions. Entire industries built on the bounty of the sea now face collapse, with ripple effects reaching far inland. It weakens the ocean's ability to regulate our climate and produce the oxygen we breathe. The decline of phytoplankton and other foundational organisms disrupts the global carbon cycle, with consequences for the entire planet. The silent, interconnected world beneath the waves is sending a clear and urgent message. Its pillars are falling. The warning signs are everywhere, if we choose to see them. The intricate web of life, woven over hundreds of millions of years, is fraying under the strain of our actions, and the consequences of its unraveling will be felt by all of us. The cascade of collapse is not inevitable, but it is accelerating. And only a profound change in how we value and protect the ocean can halt its advance. In the face of such widespread ecological decline, it is easy to feel a sense of despair. The ocean, once teeming with vibrant life, now bears scars of human impact, its silence echoing the loss of entire ecosystems. The scale of the challenges facing our oceans, overfishing, habitat destruction, climate change and invasive species, is immense. Each threat weaves a complex web, unraveling the delicate balance that has evolved over millions of years. Yet, amidst these sobering realities, there are powerful stories of recovery that offer a profound message of hope. The ocean's healing is not just a return to what was lost, but a dynamic process of renewal, adaptation, and transformation. These examples demonstrate that the ocean possesses a remarkable capacity for resilience. Even in the most unlikely places, life finds a foothold, and the process of regeneration begins, often in ways that surprise even the most seasoned scientists. When the pressures are removed and ecosystems are given a chance to heal, life can return with surprising speed and vigor. Coral polyps build new skeletons, kelp forests rise from the depths, and entire food webs reassemble, layer by intricate layer. These glimmers of hope are not just comforting anecdotes. They are crucial blueprints for a more sustainable future, showing us that positive change is possible when natural processes are allowed to unfold. One of the most inspiring comeback stories is that of the great whales. These ocean giants, once nearly silenced, now fill the seas with their haunting songs and powerful presence. After being hunted to the brink of extinction for centuries, species like the humpback and grey whale were granted protection under international agreements in the 20th century. Freed from relentless pursuit, they began a slow but steady return. The results have been nothing short of miraculous. Whale populations, once reduced to mere shadows of their former abundance, now pulse with new life, their migrations spanning entire ocean basins. Humpback whale populations in the South Atlantic, once reduced to just a few hundred individuals, have rebounded to over 25,000, nearly 90% of their pre-whaling numbers. Their resurgence is a testament to the ocean's ability to recover when given the chance. Similarly, the Eastern Pacific grey whale population has made a full recovery, their ancient migratory routes once again alive with the movement of these resilient travellers. These majestic creatures, once symbols of loss, are now symbols of successful conservation, proving that when destructive practices end, nature can and will bounce back, often in ways more spectacular than we imagined. On a more local scale, the establishment of marine protected areas has shown tremendous success in restoring marine biodiversity. These underwater sanctuaries become living laboratories of renewal. When a section of the ocean is closed to fishing and other extractive activities, it becomes a sanctuary where marine life can thrive undisturbed, and ancient rhythms are restored. Inside these protected zones, fish populations grow larger and more numerous. Apex predators return, and the intricate dance of predator and prey resumes, strengthening the entire ecosystem. This spillover effect benefits surrounding areas as the abundant fish move out and repopulate depleted fishing grounds, restoring balance beyond the sanctuary's borders. The rapid recovery seen within well-managed marine protected areas, from the flourishing coral reefs of the Caribbean to the teeming kelp forests of California, provides undeniable evidence that giving the ocean space and time to recover is one of the most effective tools we have for conservation. Even in the fight against invasive species like the lionfish, the ocean's healing is visible. As these predators are removed, native species reclaim their niches, and the intricate tapestry of reef life is rewoven. In places where lionfish populations are controlled, native fish rebound, coral health improves, and the reef's natural defenses are restored, demonstrating the ocean's ability to self-correct when given the opportunity. Each of these stories, of whales returning, of reefs regenerating, and of invaders being controlled, carries the same powerful lesson. The ocean's power to heal is both intricate and profound. The ocean is not a lost cause. It is a living, breathing system capable of astonishing renewal when given the chance. It is a dynamic and resilient system that responds positively to even the smallest acts of stewardship, its currents and cycles working tirelessly to restore balance. The ocean's healing is written in the language of renewal. Corals spawning under moonlight, plankton blooms nourishing the food web, and ancient cycles of migration resuming across vast distances. These successes should inspire us not to complacency, but to greater ambition. The ocean's power to heal is a testament to the resilience of life itself, a reminder that given space and time, even the most wounded ecosystems can flourish once more. Our exploration began with a simple question: what truly makes a fish dangerous? Along the way, we encountered the formidable Dunkleosteus, the ancient predator whose bite could shatter bone, and the shark, whose presence maintains the delicate balance of marine ecosystems. We witnessed the havoc wrought by invasive lionfish and the quiet, essential role played by anchovies, tiny fish that underpin entire food webs. But as we look deeper, it becomes clear that danger in the ocean is not defined by sharp teeth or venomous spines. The greatest threats arise when the intricate connections that sustain life are broken, when the loss of a single species ripples outward, destabilizing the systems that support all life on Earth. Today, the most profound danger to the ocean comes not from its inhabitants, but from us. Our choices, what we consume, how we fish, the waste we produce, have consequences that reach every corner of the sea. The health of the oceans and the future of humanity itself now rest in our collective hands. The science is clear. Marine ecosystems, shaped by hundreds of millions of years of evolution, are unraveling at a pace never before seen. Overfishing, pollution, and climate change are eroding the diversity and resilience of ocean life. We have become the ocean's apex predator, and our influence is felt from the shallowest reefs to the deepest trenches. Yet, within this sobering reality lies hope. We possess the knowledge, the technology, and the proven strategies to reverse course. Marine protected areas have demonstrated that, when given a chance, ocean life rebounds with astonishing speed. Sustainable fisheries show that it is possible to feed people while allowing fish populations to recover. Restoration projects reveal that damaged habitats can be brought back to life. The responsibility for safeguarding the ocean is shared by all. Governments must enact and enforce strong protections, establish vast reserves, and eliminate harmful subsidies that drive overexploitation. Industries must innovate, adopting cleaner technologies and sustainable practices that reduce their impact on marine environments. But the power to shape the ocean's future also lies with each of us. Every decision, from the seafood we purchase to the products we use and the causes we support, sends a signal. By choosing sustainably sourced seafood, reducing single-use plastics, and supporting conservation initiatives, we become active participants in the ocean's recovery. Even those far from the coast are connected to the sea. Rivers, lakes and streams carry our actions downstream, ultimately joining the vast blue expanse that covers most of our planet. The ocean's fate is inseparable from our own, no matter where we live. The coming years represent a pivotal moment. If we act decisively and together, we can secure a future where marine ecosystems flourish and human communities thrive. The ocean's resilience is remarkable. It has shown time and again its capacity to heal when given the chance. Our shared responsibility is to ensure that this healing continues. By working collectively across nations, industries and communities, we can preserve the ocean's wonders for generations yet to come. The story of life on Earth is written in the sea. Let us write the next chapter with wisdom, compassion and resolve, so that the ocean's story endures far into the future. Beneath the waves, an ancient arms race has unfolded for hundreds of millions of years. A silent contest not just of jaws and speed, but of chemistry. Here, danger often arrives in the most unexpected forms. A brush with a fin, a graze against a spine. This is the hidden world of venomous fish, where survival hinges on molecular innovation. The story begins in the dim, murky shallows of prehistoric seas. Early fish, vulnerable to predators and competition, evolved myriad defenses: armor, plates, camouflage, and, in a few remarkable lineages, the ability to produce venom. Over time, this trait would emerge independently in more than 2,000 species, each refining its own unique cocktail of toxins. Visuals glide past the spiny lionfish, its delicate fins laced with venom-filled grooves. In slow motion, a predator brushes too close, recoiling instantly from the sting. A vivid reminder that beauty in the ocean can conceal danger. The camera then sweeps across the sandy bottom, revealing the well-camouflaged stonefish. Motionless and nearly invisible, it waits for an unwary victim to step too close, delivering one of the most potent venoms in the marine world. But venom is not always a weapon of attack. For the weaverfish, lurking beneath the sand, toxin-tipped spines are a last line of defense, deterring would-be predators with swift, searing pain. For the humble catfish, scattered across rivers and coasts, venomous spines offer protection in the crowded, competitive world of the shallows. Each species' venom is a masterpiece of evolution, a blend of proteins and enzymes precisely tuned to disrupt nerves, paralyze muscles, or inflict agony. These molecular weapons are shaped by the pressures of survival, honed over countless generations. Some venoms immobilize prey, others deter larger threats, and a few may even serve as warning signals, advertising the cost of attack. Yet, the evolution of venom has not only changed the fate of individual fish, it has reshaped entire food webs. Predators learn to avoid the warning colors and elaborate displays of venom species, while competitors are kept at bay. In this way, the presence of venom can ripple outward, influencing patterns of predation and competition across the reef. Despite their fearsome reputations, venomous fish are not villains. Their existence is a testament to the creative force of evolution, finding solutions where brute strength alone would fail. Through these subtle weapons, life in the ocean finds new ways to endure, adapt, and thrive. As we witness these remarkable adaptations, we are reminded that the ocean's greatest marvels often lie just beneath the surface, hidden in plain sight, waiting to be discovered. In the delicate tapestry of ocean life, every species holds a place, woven over eons of evolution. But sometimes an outsider arrives, an invader, introduced by accident or design, carrying with it the power to unravel ancient balances. Visuals fade in on dense schools of native fish, darting among vibrant coral. Suddenly, a shadowy newcomer appears, the voracious lionfish gliding with effortless grace. Its feathery fins belie a relentless appetite. In waters far from its native Indo-Pacific range, the lionfish devours young reef fish at an astonishing rate. With few natural predators, its numbers explode, crowding out native species and leaving empty spaces where diversity once thrived. Cut to underwater grass beds. The camera tracks a silent transformation as non-native tilapia and carp stir up sediment, clouding the water and smothering fragile habitats. Invasive gobies, small but aggressive, compete with local fish for food and nesting sites, upsetting the careful balance that sustains the food web. Each invasive species brings its own ripple effect. Some outcompete locals for resources, others alter habitats, and a few introduce new diseases. The result is often a cascade of unintended consequences. Coral reefs lose their grazers, algae grows unchecked, and once thriving fisheries collapse. Yet the story is not only about loss. Occasionally, native predators adapt, learning to hunt the invaders. Ecosystems may shift, finding new points of balance, but not without cost. As the visuals pan across a patchwork of changing reefs and silty riverbeds, the message is clear. The arrival of an invasive species is never a simple addition. It is a force that reshapes the entire ecosystem, challenging the resilience of the ocean's communities and testing the limits of adaptation. The ocean's story is one of constant change, but the scars of invasion can last for generations. Only by understanding these subtle, sweeping impacts can we hope to protect the fragile networks that sustain life beneath the waves. Beneath the sunlit waves, far beyond the reach of day, lies a world shaped by darkness and pressure. Here, in the silent, crushing depths, survival demands innovation. Enter the deep-sea predators, creatures forged by extreme conditions, each bearing remarkable adaptations that defy imagination. Visuals dissolve into the eerie blue-black of the abyss. A fangtooth fish emerges, its oversized jaws bristling with needle-like teeth, perfectly designed to seize scarce prey in the pitch-black gloom. Nearby, the sleek shadow of a black dragonfish glides by, its body lined with bioluminescent organs. These glowing lures flicker, mimicking the faint glimmers of smaller creatures, drawing victims ever closer to a deadly maw. Cut to the ghostly outline of a gulper eel. Its immense, distensible mouth swings open, capable of engulfing prey nearly half its own size. An essential adaptation where meals are rare and every opportunity must be seized. The camera lingers on the subtle movement of a six-gill shark, its ancient lineage evident in its streamlined form and slow, deliberate hunt. Unlike their shallow water relatives, these sharks conserve energy, striking only when success is nearly certain. Zoom in on a pair of glowing eyes. The barrel-leaf fish, with its transparent head, scans upward for silhouettes of unsuspecting prey against the faint shimmer of distant surface light. Its tubular eyes rotate within its skull, maximizing the chances of a successful ambush. Throughout this shadowy realm, bioluminescence is the language of both hunter and hunted. A flash here, a pulse there, sometimes a lure, other times a warning. Visuals intercut between predatory fish and the ephemeral fireworks of their light, synchronized to the rhythm of the deep. In the darkness, every adaptation is a response to scarcity. Elongated jaws, expandable stomachs, light-producing organs, and senses honed to detect the faintest trace of movement or chemical cue. These are not monsters, but masterpieces of evolution, each uniquely equipped to thrive where few others can survive. The deep sea is a realm of perpetual night, but in its cold embrace, the ocean's most enigmatic predators reveal the boundless creativity of life itself. In the endless expanse of the ocean, survival often hinges on the art of being unseen. Here, camouflage and mimicry are not merely defenses. They are refined weapons wielded by the ocean's most dangerous fish. The scene opens with the gentle sway of kelp forests. Amidst the shifting shadows, a stonefish lies perfectly motionless on the sandy floor. Its mottled skin, textured and coloured to match the surrounding rocks and coral, renders it nearly invisible. Only when an unwary prey fish drifts within striking range does the stonefish betray its presence, exploding into motion with lightning speed. Transition to the open reef, where the lionfish hovers, its flowing fins mimicking the gentle undulations of nearby sea anemones. The lionfish's bold stripes don't just warn of its venom. They also break up its outline, making it difficult for both prey and predators to pinpoint its exact shape. The camera lingers on the subtle interplay of light and shadow, illustrating how disruptive coloration confuses the eye and buys precious seconds for an ambush. Cut to the fluttering silhouette of a leaf scorpionfish. Its body sways in perfect synchrony with drifting algae, each movement choreographed to the rhythm of the current. This living illusion allows it to blend seamlessly into the seascape, deceiving both those it hunts and those who hunt it. Deeper still, the mimic octopus glides across the seabed. Though not a fish, its mastery of disguise is legendary. With a flick of its arms and a shift in coloration, it transforms into the likeness of venomous sea snakes, flatfish, or even lionfish, each mimicry tailored to the threats and opportunities of the moment. Back among the coral, the reef stonefish and the tasseled wobbegong showcase another strategy: aggressive mimicry. Their cryptic patterns not only hide them from predators, but also lure prey into a false sense of security, bringing unwitting victims within lethal reach. Across the ocean's many realms, camouflage and mimicry are the silent strategies that shape life and death. From the shifting sands to the intricate reefs, these masters of deception prove that in the underwater world, what you see is rarely what you get. Perfectly synchronized, the visuals reveal the elegance of these adaptations. Skin that changes color in an instant, fins that flutter like leaves, and eyes that watch, always waiting, always hidden. In the ocean, the greatest dangers are often those you never see. Beneath the shimmering surface, coral reefs pulse with life, a kaleidoscope of color and movement shaped by a delicate balance. Here, dangerous fish are not just inhabitants. They are pivotal players in an ancient drama. The scene opens with a panoramic sweep over a bustling coral city, every crevice teeming with creatures. Among the corals, a moray eel weaves through labyrinthine tunnels, its sleek body gliding with predatory grace. It is both guardian and hunter, patrolling the reef's hidden corridors, preying upon the weak and the unwary. Cut to a school of parrotfish, their vibrant scales flashing as they graze on algae. Suddenly, a shadow darts from behind a coral head, a reef shark. With calculated precision, it disperses the school, its presence an unspoken force that keeps populations in check. The camera lingers on the aftermath, showing how the shark's predatory role prevents any single species from dominating, allowing coral polyps to thrive and maintain their intricate structures. Transition to a venomous cone snail, gliding across the sandy patches between coral outcrops. Its hunting is silent, but its impact is profound, controlling populations of small fish and invertebrates that might otherwise overwhelm the fragile coral branches. Meanwhile, a pair of triggerfish patrol the reef, their powerful jaws capable of cracking open the armored shells of sea urchins. By keeping urchin numbers in balance, these fish prevent the overgrazing of coral and help preserve the reef's architecture. The visuals shift to a lionfish, its spines unfurled like a living warning. An invasive presence in some regions, it hunts relentlessly, consuming juvenile fish and threatening the reef's diversity. Yet even its predation is woven into the web. Predators and prey locked in an endless cycle that shapes the fate of the entire ecosystem. Interwoven through every frame, the message is clear: dangerous fish are neither villains nor mere survivors. They are architects of equilibrium, sculpting the reef's future with every hunt and every escape. Without them, the coral's vibrant tapestry unravels, leaving only silence and ruin. In the coral reef's grand design, even the most formidable hunters are part of a fragile, beautiful balance, one that demands respect, understanding, and protection. As dawn breaks over the world's oceans, the silhouettes of dangerous fish glide through shifting currents, their futures more uncertain than ever before. The threats they face are both ancient and alarmingly new, woven into the very fabric of a changing planet. We begin with a sweeping aerial view of a reef scarred by bleaching, its colours faded beneath the relentless advance of warming seas. Within these ghostly structures, a solitary reef shark patrols, its presence a reminder of balance now teetering on the edge. Ocean acidification, invisible yet relentless, weakens coral skeletons and disrupts the sensory cues that predatory fish rely on to hunt and navigate. Cut to the open ocean, where ghost nets drift like spectres, silent traps ensnaring barracuda and groupers alike, their struggles unseen in the vast blue wilderness. Illegal and unregulated fishing casts a long shadow, targeting apex predators for their fins, teeth, and flesh. The disappearance of these keystone species triggers ripple effects. Prey populations explode, algae smothers corals, and entire ecosystems unravel. But hope glimmers in the currents. The camera transitions to a network of underwater sanctuaries, marine protected areas where dangerous fish thrive. Here, the population of once rare groupers rebounds, and the intricate dance between predator and prey resumes its ancient rhythm. Scientists deploy remote-operated cameras and acoustic tags, tracking the secret migrations of hammerhead sharks and moray eels, gathering crucial data to inform new protections. In another frame, artificial reefs are lowered onto sandy seafloors. Steel skeletons soon swarmed by curious lionfish, triggerfish, and juvenile snappers. Over time, these structures bloom into new habitats, offering refuge for both hunters and the hunted. Coral fragments are transplanted by robotic arms, restoring lost architecture and inviting the return of the reef's most formidable residents. Throughout the sequence, vivid infographics overlay the scenes: rising sea temperatures, declining fish populations, and the expanding reach of conservation zones. The message is clear. Without decisive action, the ocean's most dangerous inhabitants may vanish, taking with them the balance that sustains all marine life. Yet every effort, each sanctuary established, each law enforced, each coral restored, writes a new chapter of resilience. In the end, the fate of dangerous ocean fish is inseparable from our own. Their survival is not just a battle for their species, but a testament to the ocean's enduring power to recover, adapt, and thrive, if given the chance. The Crossroads is here. The next move is ours.